Did you know over 80% of jerky throttle issues come from one sensor? What is a throttle position sensor? Today, I'll share 3 quick throttle position sensor secrets to fix your motorcycle's jerky throttle. The throttle position sensor, or the TPS, is a small device on your throttle body that sends voltage signals to your ECU. It reads your grip position, sending a smooth voltage from 0.6 volt when closed to 4.2 volt when wide open, telling the ECU how much fuel to inject, when to adjust ignition timing, and how to control idle. Whether your bike's carbureted or fuel-injected, sport or cruiser, the TPS links your right hand to your engine's computer. You'll find it bolted to the throttle body or carburetor. Let's uncover 3 telltale secrets to fix jerky throttle before wasting money. Secret 1. The hidden voltage test. The throttle position sensor, your TPS, tells your ECU exactly where your right hand is. Closed throttle, half throttle, wide open. It sends one smooth voltage signal that climbs steadily as you twist the grip. When that signal gets choppy or irregular, your ECU gets confused. It can't tell where your throttle actually is, so it guesses. Sometimes it guesses rich, sometimes lean, sometimes it cuts fuel entirely. That's why your bike lurches and stutters. The computer is working with bad data. Before you buy a single part or pay for a dyno tune, run the 5-minute voltage sweep test. Key on, engine off. Back probe the TPS signal wire with your multimeter. Set it to DC volts. Now slowly ease the throttle from fully closed to wide open while watching the voltage reading. You want a clean, steady climb from about 0.6 volts at closed throttle to around 4.2 volts at full throttle. No spikes, no drops, no flat spots anywhere in between. If the voltage hiccups, stalls, or jumps at any point in that sweep, you found your problem. That choppy signal is creating every hesitation, stumble, and backfire you're experiencing. Garbage data in, garbage performance out. This single test has saved riders thousands in unnecessary repairs. I had a customer who'd been chasing throttle issues for over a year. He'd paid for 2 ECU reflashes, replaced his fuel injectors, and even swapped out his fuel pump. Total cost, nearly $900. The bike still felt like garbage. We ran the voltage sweep test and found a flat spot at 3.5 volts where the signal just stopped climbing. Installed a new TPS, did the ECU relearn procedure, cleaned the connector, problem solved. The bike idled like a metronome and pulled smooth from bottom to top. All that bad mapping was just bad data from one worn resistive track inside a $60 sensor. Here's what most riders don't realize. Ignoring a failing TPS creates a domino effect of damage throughout your entire fuel and ignition system. Perfect. Jerky throttle makes you compensate by rolling on harder than you need to. That dumps extra fuel into the cylinders. Rich mixtures create carbon deposits on spark plugs and valves. Hot, dirty combustion batters your oxygen sensors and eventually destroys your catalytic converter. Meanwhile, your ECU's long-term fuel trims start wandering because it can't trust the throttle position data. 6 months later, you're staring at a pile of failed parts wondering how it started. It started with a sensor that costs less than your helmet visor. The cheapest fix is always the earliest fix. A Triumph Street Triple came in lunging at steady throttle and backfiring like a shotgun on Dussel. 2 different shops had flashed the ECU twice and billed the owner almost $900. He was ready to sell the bike. We put the multimeter on the TPS signal wire and did the voltage sweep. At about 3.5 volts, the reading fluttered and jumped like a bad heart rhythm. We swapped the sensor, performed the relearn procedure, cleaned the connector with electrical contact cleaner, and verified all the grounds were solid. The voltage held rock solid through the entire sweep. The owner came back from his test ride grinning. It rides like a completely different bike. That's the power of starting with the sensor and its signal. If your data is wrong, everything you tune on top of it will be wrong too. One more thing, heat can make a borderline TPS worse. If your throttle response is mostly fine when cold, but gets snatchy after 15 minutes of riding, that's the resistive track inside expanding from heat. The wiper loses clean contact with the track, and your signal goes to hell. Catch it with the voltage sweep test before it catches you mid-corner. And when you're cleaning your throttle body, don't drown the TPS in throttle body cleaner. Keep the solvent away from the sensor shaft. That stuff can wick past the seals and attack the resistive track inside. A few careful sprays where the throttle butterfly lives is all you need. That voltage sweep test reveals sensor failures instantly, but here's what catches most riders off guard. Sometimes the TPS itself is perfectly healthy, but the ECU is reading it all wrong. When that happens, even a brand new sensor won't fix your jerky throttle. The second secret fixes this invisible problem in 30 seconds. Before we jump to the next secret, drop a comment below. Have you ever run the voltage sweep test yourself? Tell me what your readings looked like, or if you found that flat spot hiding in your throttle signal. Secret 2. The TPS reset trick. Sometimes your TPS is electrically perfect. Clean voltage sweep, solid connections, good ground. But the ECU is still interpreting the signal incorrectly. This happens after battery replacements, throttle body cleanings, or anytime the bike sits with the battery disconnected. Here's what's happening. Your ECU stores a baseline reference for closed throttle position. If it learns the wrong baseline, say it thinks 0.8 volts is closed throttle when it should be 0.6 volts. The computer thinks you're constantly holding a tiny bit of throttle even when your hand is off the grip. That throws off everything. Idle control gets weird. D-cell fuel cut doesn't work right. Part throttle fueling becomes unpredictable. Your entire fuel map shifts because the reference point is wrong. The fix is free and takes less than a minute. Key off. Make absolutely sure the throttle is fully closed. Key on, but don't start the engine. Slowly twist the throttle from fully closed to wide open and back to fully closed. Do this twice, smoothly and deliberately. Key off, count to 10. On most Japanese bikes, Yamaha, Honda, Suzuki, this simple procedure teaches the ECU the real voltage range of your TPS. The computer now knows where 0 lives and where full throttle lives, so everything in between makes sense again. On some European bikes, you'll need a diagnostic scan tool, but the principle is the same. A clean baseline reset saves you from cascading problems. When the ECU thinks closed throttle is slightly open, your idle air control valve fights against the fuel map constantly. That tug of war fouls spark plugs, overheats the catalytic converter, and cooks your exhaust header pipes. All from a bad baseline that takes 30 seconds to fix. Here's a bonus tip that'll make your TPS last longer. Stop the key-on blip habit. Every time you twist the throttle, the wiper inside scrubs across the resistive track. I had a customer who'd turn the key on and blip the throttle a few times before starting. He burned through 2 TPS units in 18 months. Almost $400 in sensors for a habit that added 0 benefit. The reset secret pairs with simple maintenance habits. Anytime you clean the throttle body or disconnect the battery, do the relearn procedure. Keep your battery healthy so the ECU's 5-volt reference stays rock solid. Don't cinch zip ties so tight they bite into wire insulation. Support the harness so turning the handlebars doesn't flex the TPS connector with every steering input. Once you've done the relearn, you should feel the difference immediately. The idle settles into a steady rhythm. That first crack of throttle stops feeling like flipping a light switch. Rolling off and back on in traffic goes from jerky to buttery smooth. If the reset makes no difference, or if the smoothness fades as the bike warms up, don't start guessing. Move directly to Secret 3. That's where the invisible voltage thieves hide. The relearn procedure fixes ECU baseline errors instantly. But there's one more villain that causes jerky throttle, even with a perfect sensor and fresh calibration. The third secret reveals the wiring problem that fools mechanics and costs riders over $1,200 when it goes undiagnosed. Secret 3. The ground loop fix. You can have a perfect TPS and a fresh ECU relearn, and still fight jerky throttle. When that happens, the wiring is your villain. The TPS needs two things: a clean 5-volt reference supply and a solid ground connection. Any corrosion, moisture, or loose pins in the connector add resistance to the ground path. Even 0.3 ohms of resistance makes the voltage signal float and wander. The ECU sees a twitchy voltage reading and thinks your wrist is vibrating, creating phantom throttle inputs. Start with the connector. Unplug the TPS connector and inspect both halves under good light. If you see green dust or crusty deposits on the pins, that's copper oxide corrosion. Spray both sides with electrical contact cleaner and let it evaporate completely. Check the pin tension. Loose pins create intermittent contact that arcs and chews up the voltage signal. Add a tiny dab of dielectric grease to seal out moisture, then reconnect firmly. Now test the ground under load. Set your multimeter to DC volts. Put one lead on the TPS ground wire and the other on your battery negative terminal. Key on, engine off. Turn the handlebars lock to lock. Wiggle the wiring harness. Turn on the cooling fan, headlight, and high beam. Watch that voltage reading. Anything above 0.1 volts means you have ground resistance contaminating your sensor signal. If the voltage jumps when you add electrical loads, your ground connection is compromised. Fix it by cleaning the frame ground lug down to bright, bare metal. Remove paint, rust, and corrosion with a wire brush. Retorque the ground bolt to proper spec. If the factory ground point is corroded beyond salvation, add a short dedicated ground strap from the sensor ground to a known good ground point. Here's why this matters. A weak ground doesn't just make your throttle feel bad, it kills expensive parts. Noisy, fluctuating sensor voltage forces your ECU's input circuits to work overtime. I've seen engine computers literally cooked by unstable reference voltage that started with one crusty connector. That's a $1,200 ECU replacement that an $8 can of contact cleaner could have prevented. And if you've added electrical accessories, LED lights, heated grips, USB ports, do not share sensor grounds with those high current accessories. Ever. Keep your sensor grounds clean, separate, and dedicated. Here's how you know your fixes worked. Take a proper test ride with the bike fully warmed up. The idle should find a steady rhythm without hunting. Ease away in first and second gear. It should feel like pulling silk, not stretching rubber bands. Hold a steady 3,000 RPM in third gear. You want one smooth note, not pulsing or surging. Roll off the throttle and coast. The bike should return to idle cleanly without stumbling or backfiring. When you roll back on after a corner, power should arrive like a dimmer switch, not a light switch. Lock in these results with simple annual maintenance. Once a year, run the voltage sweep test. Every 10,000 miles, unplug the TPS connector, clean both halves, and apply fresh dielectric grease. Keep your battery healthy. After any throttle body cleaning or battery replacement, do the ECU relearn. Support your wiring harness properly. You'll spend maybe $15 per year on supplies and avoid spending $1,200 to $1,800 on the cascade of failures from unstable sensor voltage. These 3 fixes transform Jerky Throttle into smooth power delivery for under $20. But there's another problem costing riders even more at every gas station: wasted fuel from bad habits. Check out my next video where I show you how to make your tank last twice as long and save hundreds every year. Subscribe so the next breakdown you prevent and the next fuel stop you skip might be your own.